Welcome to this video on angles and polygons, increasingly difficult questions. So we've got a few questions to get through. They get more challenging as we progress. What I would suggest is that when a new question appears on the screen, you pause the video and have a go at the question first, and then check your answer with my solution. Testing yourself will be the best way for you to learn rather than watching the video straight through. Okay, let's make a start. This diagram shows an isosceles triangle. Work out the size of angle X. So we've got an isosceles triangle. That means that these two sides are the same length and these two base angles are also the same size. We should know that angles inside a triangle add up to 180 degrees. So the first step will be to subtract 35 from 180 to see what we've got left. That would give me 145. And then, because these two base angles are the same size, I can just divide 145 by 2 to work out the size of one of them. And that would be 72.5 degrees. So this angle X here is 72.5 degrees. Okay, let's look at this one. The diagram shows a regular six-sided polygon. Work out the value of y. So y is actually an exterior angle of this six-sided polygon. There are 6 of them here. And if you remember this, welcome to this video on angles and polygons, increasingly difficult, 360 degrees. So because it's regular, each of these angles are the same size. There are 6 of them, so we just need to do 360 divided by 6, which gives me 60 degrees. So the angle Y is just 60 degrees. Okay, let's look at the next one. So this diagram shows a regular 5-sided polygon. Work out the value of X. There are 2 ways to actually do this question. The first is using the method we just used in the previous video. So the first thing I want to do is draw in my exterior angle here. So my exterior angle and my interior angle add up to make 180 degrees. So if I can work out how big this exterior angle is, I can subtract it from 180 to work out X. Now I know that there are 5 of these exterior angles and they all add up to make 360. So if I do 360 degrees divided by 5, that gives me 72 degrees. So that means that this exterior angle here is equal to 72 degrees. Now, remember I said that these two should add up to make 180. So if we do 180 degrees minus 72 degrees, that gives me 108 degrees, which is therefore the size of angle X. So this one here is 108 degrees. So that's the first way to work out this question. The other way to work out the size of this angle X is by using the sum of the interior angles of a polygon. So remember the sum is equal to n, the number of sides, take away 2 to give us the number of triangles, and then multiply by 180 degrees. So in this case, n is 5, because there are 5 sides. So the sum is going to be equal to 5 take away 2 and then multiply by 180 degrees. 5 take away 2 is 3 and 3 lots of 180 is equal to 540. That means the sum of all the angles inside this 5-sided polygon is 540. Now because it's regular, each angle is the same size. So to work out the size of one, I would just need to do 540 degrees divided by 5, which is 108 degrees. So again, we've got angle X is 108 degrees. Next question. 4 of the angles of a pentagon are 95 degrees, 112 degrees, 131 degrees, and 84 degrees. Work out the size of the 5th angle. Right. We need to know the sum of all the angles in a 5-sided shape to start with. If I know what they all add up to make, then I can use that to work out the size of my missing angle. So this one here is the 5th angle. Again, we can use the rule for the sum of the angles inside a polygon. That's n minus 2 and then multiplied by 180 degrees. So n is 5 because there are 5 sides. 5, take away 2, and then multiplied by 180. So that's 3 multiplied by 180 degrees, which is equal to 540 degrees. So I know that the sum of these angles is 540. So to work out this angle here that's missing, I just need to add together these 4 first. So 84 plus 131 plus 112. Welcome to this video on angles and polygons, increasingly difficult questions. Do 540, which is all 5 of them, subtract 422, which is the other 4, to work out my missing angle. So 540 subtract 422, that gives me 118. So this angle here is 118 degrees. Okay, the next one. A regular polygon has an exterior angle of 15 degrees. Work out the number of sides of the polygon. So it's told us the size of one of the exterior angles, and it's asked us to work out the number of sides. So because it's regular, all of the exterior angles are going to be 15 degrees. They're going to be the same size. This question doesn't actually have a diagram attached to it, so if there isn't a diagram, what I would recommend is for you to draw one to help you visualize what the question is asking for. So I'm going to draw in a couple of the exterior angles just so that you can see. So imagine there's one here, 15 degrees, there'd be another one here, which is 15 degrees, and so on and so forth. So I want to know how many of these 15 degree angles there are to make up 360. How many 15s go into 360? So that's 360 divided by 15. That tells me how many of these angles there are around the exterior of my shape. If I put that in a calculator, that gives me 24. So there must be 24 of these. And because there are 24 angles, there are therefore 24 sides. So the number of sides is equal to 24. Okay, the next one. The diagram shows a regular 8-sided polygon with center 0. Work out the value of x. Right, so looking at this, x is inside a triangle, and it's the top angle inside the triangle. So the first thing to notice is that this octagon has been divided into 8 triangles, and these triangles are exactly the same size, and they have the same angles in them. How do I know this? Well, they're all drawn from the center to the edge. So these lines must be the same length, as are these lines, as are these lines, and so on and so forth. And they all have the same base. Because it's a regular polygon, these are the same length. So that means that these 8 triangles are all the same size, which means that this angle at the top is the same size as the angle at the top of my other triangles as well. And if I draw all of these in, you'll see that I get a full turn. So if I want to work out the size of one of these angles, and there are 8 of them, a full turn is 360 degrees, so I would do 360 divided by 8, and that gives me 45, which means the angle at the top of each of those triangles is 45. So this angle here is 45 degrees. Okay, let's have a look at this one. The diagram shows a regular octagon with center O. Work out the value of x. So the first thing to notice is that this octagon is essentially the same as the one in the previous question, except here we have the 8 identical triangles drawn in. And in this question that we're tackling now, they haven't been drawn in. We've only been left with one triangle, but we're going to use the workings out from the last example to help us with this one. Namely that the angle at the top here is 45 degrees. The next thing to notice is that this triangle is actually an isosceles triangle. These two sides here are equal in length because they're both drawn from the centre to the edge of a regular polygon. So I'm going to draw in my lines to show that they're equal, which means that these two bottom angles are also equal as well. So now we can just use the fact that angles in a triangle add up to 180 to help us work out what x is. So we would do 180 subtract 45, which is equal to 135 degrees, and then I could just divide that by 2 to work out each of these base angles. So 135 divided by 2 is equal to 67.5 degrees, which means x here is 67.5 degrees. Okay, let's have a look at this one. So the diagram shows 3 identical regular pentagons. Work out the value of y. So you can see angle y is tucked in between these 2 pentagons here. It actually forms a full turn with these 3 angles here. 1, 2, and 3, which is pretty cool. So all 4 of those would add to make 360 degrees, and we can use that fact to help us work out what y is. The other thing to notice is that each of these angles is an interior angle in a regular pentagon. So, how do we work out one of these angles? There are 2 ways to do this. I'm going to use the sum of the angles rule to help us do this. So the sum of all the angles in a polygon is n minus 2 multiplied by 180. N is 5. 5 take away 2 is 3. So we need to work out 3 lots of 180, which is equal to 540. Okay, so all the angles within this 5-sided shape equal 540. Because it's regular, they're all the same size, means that this angle here is going to be 540 divided by 5, which is 108 degrees. So this angle here is 108. So is this one, because this is also a regular pentagon, and so is this one. So my next step would be to multiply 108 by 3 to work out what the total is from those 3 angles, and that would be 324 degrees. And then all I need to do is take that away from 360 to work out what y is. So 360 degrees, take away 324 degrees equals 36 degrees. So that means that y here is 36 degrees. Let's take a look at this question. The diagram shows a regular polygon with 7 sides. Work out the size of angle x and give your answer correct to 1 decimal place. So we have a regular polygon, and in it is a triangle. Because the sides are the same length as it's regular, it means that these 2 sides of the triangle are the same length, which means that these 2 base angles are the same size. And the other thing to notice is that the 3rd angle in the triangle is actually an interior angle of your 7-sided shape. So there are 7 of these, 1, 2, 3, 4, 5, 6, 7. And if we can work out how big this angle is here, we can use that to work out how big x is. So how do we work out the size of an interior angle in a polygon? Well, there are a couple of ways. I'm going to use the sum rule. So the sum is equal to n minus 2 multiplied by 180 degrees. We've got 7 sides, so n take away 2 is going to be 5. So 5 times 180 degrees equals 900 degrees. So all 7 angles add to make 900. To work out the size of one of them, I would just do 900 divided by 7, because they're all the same size. Put that in my calculator, and that gives me 128.5714 and some other numbers. Okay, so it's a non-terminating decimal. I'm not going to do any rounding yet because I don't want to have an error in my answer. So for any working out that I'm doing now, I'm just going to be storing the numbers in my calculator, and I'm not going to round till the very end. Okay, so I now know that this angle here is 128.57 and so on. I know that the angles inside the triangle must add up to 180, and that these two are the same size. So to work out x, I would do 180, take away 128.57, so on, and then divide that by 2 to work out x. So this is what I type into my calculator. And that would give me 25.7142 and so on. It's asked me to round it to one decimal place. The first decimal place has the digit 7 and the second decimal place has the digit 1. 1 is smaller than 5, so the 7 is going to stay the same. So my final answer is going to be 25.7 degrees. So angle x here is 25.7 degrees. Okay, let's look at the next one. Here is a regular 10-sided polygon. Work out the value of x. So the first thing I notice is that there are 2 triangles inside my shape. And these are actually isosceles triangles because all the sides are equal, meaning that these 2 sides are equal. And so are these 2. And then we must have 2 base angles that are equal as well. The next thing I notice is that angle x is tucked in between these 2 triangles. And angle x, when it's joined with this angle here and this angle at the top here, actually forms an interior angle of my 10-sided polygon. So if I can work out the size of the interior angle, and I can work out the size of these little angles in brown here as well, I can do a subtraction to help me work out what x is. So let's start off by working out the size of the interior angle. Well, to do that, first we can work out the sum of all the angles. So the sum of the angles in a polygon is n take away 2 multiplied by 180, where n is the number of sides. We've got 10 sides. 10 take away 2 is 8. And 8 multiplied by 180 is 1,440 degrees. So all 10 angles add to 1,440. They're all the same size. So to work out one of them, I would do 1,440 divided by 10. And that's 144 degrees. That means that each of these interior angles is worth 144 degrees. If I kept going round, you would see that I have an interior angle in here as well. So this angle here is 144 degrees. And so is this angle in this triangle here. So if I want to work out the size of one of these 2 base angles, I would just do 180, take away this top one, 144, and then divide it by 2. So let's do that. 180 subtract 144, and then divided by 2 equals 18 degrees. So that means one of these small base angles is 18 degrees, and so is this one here. Great, now I've got all the information I need to work out x. Remember, these 3 angles make an interior angle, which is 144. So I would need to subtract this 18 degree angle and this 18 degree angle from 144 to leave me with x. So I need to do 144, subtract 2 lots of 18, which is 36, and that leaves me with 108 degrees. So that means that x is 108 degrees. Okay, here's our final question. The diagram shows an incomplete regular polygon. The size of each interior angle is 150 degrees greater than the size of each exterior angle. Work out the number of sides the regular polygon has. Okay, so the number of sides is the same as the number of interior or exterior angles. So my thoughts are, if we can work out the size of the exterior angle, We can use that to work out how many exterior angles we have and therefore how many sides we have. So let's call the size of the exterior angle the letter x, and use this to write down an expression for the size of the interior angle. Back in the question, it says the interior angle is 150 degrees greater than each exterior angle. So the way we'd write that down is x add 150 degrees. Now we can use the fact that these two angles, the interior and exterior, add together to make 180 degrees to form an equation. And the equation would look like this: x plus 150, so that's the interior angle, plus x, that's the exterior angle, equals 180. And I can solve this equation to help me work out x. I can add the two x's together, so that's 2x and then plus 150 equals 180. I can subtract 150 from both sides of the equation, so that leaves me with 2x is equal to 30. And then I can divide both sides of the equation by 2, and that gives me x is equal to 15. So that means that my exterior angle here is 15 degrees. So I can work out how many of these there are by using the fact that I know that all the exterior angles would add together to make 360 degrees. So I would just do 360 divided by 15, and that gives me 24. So there must be 24 of these 15-degree angles, therefore we have 24 sides. So the answer is 24. Okay, that brings us to the end of this video. If you found this lesson helpful, please do give this video a like and subscribe to my channel. I'm just at the very beginning of my YouTube journey and I'd really appreciate the support. See you in the next video. Bye.